I'm having elasticity on the board, and we have to talk about it. Now, elasticity is a property of an elastic material to return to its original size after being distorted by an external force. It's just like a rubber. If I get a rubber and I stretch it, it covers a what? Let's say it is being extended. Does it make sense? So under elasticity, we have what we call Hooke's law. Now, this Hooke's law says that the force applied to an elastic material is directly proportional to the extension produced. I hope it makes sense. Now, I have the force which I apply to an elastic material, and it is directly proportional to the extension produced. So I have force. If I remove this variation sign, I'll have it is equals to K E, where this K is seen as the force constant. The force what? Constant. It is a constant. And it is the force required to produce what? A unit what? Extension. Now this is force in what? In Newton. This is extension in what? In meters. If I make force constant subject of formula, I'll have that if I have that, I originally have that F is equals KE. Make a subject of formula, you have to divide both sides by what? E. When you cancel both sides, we have that force constant is equals force all over what? E. It is the force required to produce a unit what? Extension. And this is Hooke's law that I'm what? Talking about. Now, if I want to go further, if I want to go a little bit higher, I'll say that F1, because I'm having constant is equals force all over extension, I'll say that F1 all over what? E1 is equals F2 all over what? E2. So this is what is equals F3 all over what? E3. I hope it makes sense. So we've explained what elasticity means, and we've seen that there is a law under it called what? Hooke's law. And that Hooke's law says that F is equals what? Ke. Now, since we've said something like this, we've defined our terms, we have to look at the question, and the question says, a spiral spring extends from a length of 10 cm to 10.01 centimeter when a force of 20 Newton is applied on it. We have to calculate the force constant of the spring. Now, the question gave us that a spiral spring extends from a length of what? 10 cm. Now, the original length, let's call it what? L1 is what? 10 centimeter. Okay, let's move a little bit higher. So, the original length is what? 10 centimeter, right? Now, it extends from 10 cm to what? Now, the length, that's the new length, L2, which is what? 10.01 centimeter. They say that this spiral spring extends from L1, extends from 10 cm to what? 10.01 what? cm. This is the original length and this is the new length. When a force of 20 Newton is applied on it, now when a force of what? 20 Newton is applied on it, we have to calculate the force constant of the spring. Immediately we see this force constant of the spring, we'll remember F is equals Ke. Now they gave us force 20 Newton. We are looking for K, and do we know extension? We have to find extension. By me looking at it, if I have a rubber, if this is a rubber and I stretch, if the original length of this rubber is 5 meters, and when I stretch it to 7 meters, the extension has to be the new length minus original length, which should definitely be 7 meters minus 5 meters, which is what? 2 meters, right? So the original length here is 10 cm and the new length is 10.01 cm. So the extension has to be the new length minus the original length. So I'm having 10.01 centimeter minus 10.00 centimeter. So the extension is equals 0.01 centimeter. So I know force, I know extension. I want to get what? Force constant. But the extension that I know is a meter, is a centimeter. And the SI unit of length should be in meter. I hope it makes sense. Extension is a measurement of length. So the SI unit should be what? Meters. So this 0.01 cm, we have to convert it to what? Meters. We all know that 100 centimeter make one what? Meter. So we have to ask ourselves, what will be 0.01 cm in meter? 0.01 cm, what is it in meters? Cross multiply. 100 times y is 100y equals 0.01 times 1 is 0.01. So when I divide both sides by 100, all over 100, cancel, cancel. So I have that y is equals 0.01 divided by 100. I'm having two zeros under, 1, 2. So I have to move back 2 times, 1, 2. So this is points. So I'm having 0.0001 meters. So this 0.01 cm in meter, it is 0.1231 what? Meters. So let's, from our formula, we have F is equals KE. Remember, we are looking for the value of K, and we've made K subject of what? Formula somewhere here. We've made K subject of formula somewhere. Where is it? K, we have that K is equals what? FE. Look at it. So we have that since K is equals F over E, so the first constant that we are looking for, F is what? 20 all over E, which is what? 0.0001 meters. So 20 divided by 0.0001, what do I have to do? I have to remove decimal points here. So if I say times 10,000 here, times 10,000 here, so 1, 2, 3, 4. I have counts 1, 2, 3, 4. So I'm having K is equals 20. This is 200,000. 20 times 10,000 is 200,000 all over the one that I'm having under. So I'm having the first constant is 200,000. What's the unit? The unit is Newton all over 1 meter. That's Newton per meter. So my answer is what? 200,000 Newton per meter. Or you say 2 times 10 raised to power 5, 1, 2, 3, 4, 5. 2 times 10 raised to power 5 Newton per meter. That's standard form. Have a nice day, like, comment, share, and follow Courses Academy. Bye-bye.